Hi, everybody. So, welcome to Lecture 5. Sorry about the delay getting this posted. For some reason, there was a glitch in the recording in the room we were in yesterday, so it was lost completely. I do have a Zoom recording of the later part of the lecture, but I'm redoing the beginning now so that, well, you know what's going on. So this lecture is Lecture 5 on algorithms. So I'm only going to do the intro part in my living room here. I'm actually in the process of moving right now. And as you can see, that's just a bunch of boxes here. So I don't have my usual setup, and that's part of the reasons it took so long to get this lecture up. So what is an algorithm is the first question we'll ask ourselves today. And so an algorithm is, well, according to CLRS, these are the initials of the author of this algorithms textbook, an algorithm is a well-defined computational procedure that takes an input, right here, and it produces an output, right? So out here. It's just some well-defined computational procedure. And this input could be a single value, it could be a set of values, and this output could be, again, a single value or a set of values. So it's a pretty general definition. It's the one we're going to use in computer science. We can think of algorithms as a tool for solving a computational problem. So imagine we have some input-output relationship that we want. Like the input is a list, and the output is a sorted list, like we see here. An algorithm is a specific technique to take a list like 1, 9, 3, 6, 2 and produce the sorted version, 1, 2, 3, 6, 9. Okay. And so sorting is some kind of computational problem, and there are many different algorithms, as we'll see in this lecture, for producing a sorted list. So algorithms go way back, and you can think of a lot of things that humans do, even if they're not computational algorithms like in CLRS. The idea of an algorithm, it's something far older than a computer. So if you think about a dance, like a choreographed dance, or a ceremony, or a recipe, or ways to build a building, those are all conceptually similar to what we just described as an algorithm. And if you generalize the term algorithm to go beyond computation, you could say that, and indeed they are algorithms of some kind. Now, mathematical algorithms, these go way back. So Babylonians, there were a lot of fundamental procedures in mathematics that were defined 3,600 years ago. The word algorithm, in fact, comes from an Arabic root. And so I can't pronounce it, but I'll try al-Khwarizmi. I'm sure, sorry, I apologize. But he laid out many algorithms for computation that use decimal numbers. For example, the one we'll do on the next slide. So a lot of your familiar things you learned in math class, he was part of that. You've learned hundreds of algorithms over time that allow you to work with numbers, things like, well, adding, multiplication, subtraction, exponentiation, and they're obviously very important. And you could say that even in nature, there are algorithms. So DNA, in some sense, we can think of it as containing algorithms. So the DNA in your body, it somehow directs the development of your body when you're an embryo into having 5 fingers on 2 different hands for most people. And somehow that is encoded in your DNA. Okay. So let's see some examples of algorithms. One example is the algorithm for multiplying 2 numbers that you learned in school. 71 times 271, the usual procedure would look something like this. You have 71 on the top line because that's 1 times 71. Then below it, you have 7 times 71, 497, followed by a 0. And below that, we have 2 times 71, followed by 2 zeros, for a total of 19,241 after you add these 3 lines. So I'm not going to go over that obviously in detail because you should already know this. And so that's an example of an algorithm. Another example is given 2 words, report which letters they have in common. And the algorithm you might do to solve that computational problem would just be whatever you came up with for project 1. So let's start developing an algorithm together today to get a specific example of a slightly more sophisticated algorithm. So the first algorithm I'm going to do right now is finding the smallest number in a list. So given a list of 5 numbers, we want to find the index of the smallest number. So if we have 32, 39, 9, 2, and 19, we would output 4, since the smallest item is in position 4. Now at this point, the recording that I recorded in the actual room with students picks up. So I'm going to stop talking in my living room, and I'm going to pass it over to Josh from yesterday. Take it away, me yesterday.